Now we are going to work on related rates, and they can be applied in a situation like this. Let's say we have an object which is rising vertically, and here is an observer, and we know the angle of elevation theta. Now we would like to know the rate of change of the height, and you can see from this right triangle we can relate the rate of change of the height with the rate of change of the angle of elevation. All right, and if we can compute or monitor the angle rate of change of angle of elevation, then that will give us the rate of change of height at a particular instant. All right, so this is the way we will compute related rates. So let's take an example to discuss the rise of an object and apply the related rates calculation. So here is a textbook kind of example that we have a balloon that's vertically rising from a point that's 500 feet from an observer, and we know that at a particular instant when the angle of elevation is 40 degrees, the rate of change of this angle of elevation is 4.5 degrees per minute, and we want to know at what rate is the height h changing at that particular instant. So we know the rate of change of theta, and we have to determine the rate of change of h. So we would like to see if we can link h and theta by using an equation. Okay, so here is theta and h is opposite side, so we can go ahead and use trigonometry, and we will have h over 500 as tangent theta, and then just do a simple thing, multiply by 500, you get h equals 500 tangent theta, and then we carry out our differentiation. So we have the rate of change of h with respect to t, which is dh dt, is 500 times. Then you use the chain rule, secant square theta d theta dt. All right. Now d theta dt, it was given in degrees. Okay. So I think it might be a good idea to change it to radians, which I've already done. And this is the value at the instant when theta is 40 degrees. Okay. All right, so now we have this equation linking these two, so we can go ahead and substitute the values that we want dh dt, that is the rate of change of the height with respect to t at this particular moment or instant, and theta is 40 degrees, and here we have the rate of change of theta at that point, and we have the two related or linked to each other. And the product gives us what? That the balloon is rising at a rate of 68 feet per minute. Just a second, I think I did this. I mean, I was a little lazy. I did not convert 40 degrees to radians, and in this case it would not be necessary, because if you look at the definition of secant, it's a ratio, so it comes out to be the same. Even doesn't matter whether we give the input in terms of radians or degrees, but if theta or it's or say a polynomial function was of theta was directly involved, then we would have been in trouble. So be very cautious while dealing with such quantities, that even though in this case it did not matter, but it could. All right. Okay, so we are going to go and work on some other examples.